Hello, we're at the last day for logs. So first off, I said I'd go over 2 questions on the homework. The applications actually looked really good. If you had any little issues, I tried to let you know about those. It's numbers 7 and 9 I said I would go over. So 7, whenever you've got more than one log on a certain side, you've got to use log properties. Remember to combine those. So 2 logs subtracted, what's that become? 1 log divided. So log base 3 of x over 4 equals log base 3 of 12. And then how do I get rid of those logs? By exponentiating. I want to exponentiate by 3 on both sides. So I have x over 4 equals 12. And then I can just multiply by 4, and I've got my answer. X equals 48. And obviously 48 is not going to be a problem, because it's not going to be log of a negative or 0, so I'm good. And the other one I said I would do was number 9. It's there's different ways to do it. You could exponentiate by e right away, but the easiest way, when I see a 5 in an exponent and a 15 on this side, I'm thinking, well, those divide evenly. So I could make those divide if I use my log property and pull that 5 out front. So 5 ln of 4x equals 15. And then I can divide by 5. So I have ln of 4x equals 3. Now what gets rid of an ln? Ln is log base e, so I have to exponentiate by e. Now I just have 4x equals e to the third. I'll figure that out in a second. And if I want x alone, I divide by 4. So let's do e to the third divided by 4. So e to the third divided by 4. 5.02 is the nearest tenth, I think it said, so 5.0. Putting a 5 in there is not going to cause a negative or 0 log, so that's my answer. Now, a bunch of you did exponentiate by e right away. You just got big numbers. You had e to the 15th. You'd have to either distribute the exponent of 5 or take the 5th root. It just gets a little uglier. So just always remember there is this option if you can divide over an exponent that you bring out front, that you might want to do that. All right, shouldn't be too long of a video today. We have a warm-up review, so if you want to get that out. If you want to try these on your own just to see how well you're doing with logs, by all means, pause the video and then press play and see how it goes. That's what I'd have you do in class. But if you're ready to see the answers done out, here we go. Okay, if log of 5 is a, then log of 250 can be expressed how? Okay, so let's talk about the actual mathy way to do it and the way you could cheat on a test. So if log of 5 is a, I've got to get this written in terms of 5s. 250, I see 25. So if I split this up and said this was log of 25 times 10, I like that because 25 I know is just 5 squared. Why am I not really worried about this 10? This is really 5 times 2. So wouldn't I want to split that up into a 5 again? Well, the 5 would be fine, but the 2, I don't have an expression for log of 2, but log of 10 is not a problem because this is log base what? 10, so I might be able to evaluate that. Okay, so then log properties. Is everything being multiplied or is everything being raised to a power? Everything's being multiplied. So 1 log multiplied becomes 2 logs added. Log of 5 squared plus log of 10. What else can I do log property wise? I can bring the 2 out front. 2 log 5 plus log 10. And remember, once I get log 5 alone, what's that? A. So this is 2a plus log 10. This is base 10. So what's log base 10 of 10? 10 to what power gives you 10? 1. So it's choice 2. Remember, you can also kind of use your calculator. So if you know log of 5 is a, You want to find log 250, just type in what log 250 is. It's going to be a crazy decimal. There you go. This first choice is 50a. Well, a is log 5, so if you do 50 log 5, is that the same answer? Nope. 2a plus 1, again, a is log 5. If I do 2 log 5 plus 1, make sure you close the parenthesis, same decimal. That's why it's the answer. So remember, these are usually be multiple choices, and you can always use that trick. All right, number 2 is another log property thing. Expand as much as possible. So if I want to expand this is where I talk about is everything being multiplied, divided, or raised to the same power. I would say everything in here, the 2 is being raised to a power, the z kind of is too. The bottom's being multiplied, but everything inside is being divided. So that's what you got to take care of first. 1 log divided becomes 2 logs subtracted. ln of x squared minus ln of y radical z. All right, now the first one's easy. What can we do here? Right, bring the 2 out front. ln of 2 ln of x minus what's happening in here. Well, first off, whenever you've got a radical involved, I would think of it as an exponent. So this is really yz to the what power? 1/2. But is everything being raised to the 1/2? No, only the z was under the radical. So everything's not being raised to the same power, but everything is being multiplied. So 1 log multiplied, 2 logs added. ln of y plus ln of z to the 1/2. Now there is something wrong with how I have that written. This whole second piece was subtracted. So when you expand it, that whole expanded piece also has to be subtracted. Okay, so now we're going to have 2 ln of x minus ln of y. If I distribute that negative, this is minus, bring that 1/2 out front, 1/2 ln of z. And there you have it. Now, if you can skip steps, this is the one question I'm okay with you jumping right to this step if you're really good at it. If you look at your final answer, anything with an exponent is going to have that number out front. So that's why the x has a 2, the z has a 1/2. Anything on top is going to be added or positive. Anything in the bottom should have a negative in front of it. That's about it. So if you can realize those, that's how those properties will end up, I'm fine with you jumping to that step. Okay, if I ask you to find the inverse, what do you do to find an inverse? Switch x and y. So this first one would be x equals ln of 2y minus 1. Now we got to get y alone. What's my first step to that? Some of you might be thinking e. You can't exponentiate by e until the log, the ln part, is isolated. So add the 1 over first. X plus 1 equals ln of 2y. Now what? Right, now you can exponentiate by e. And it's important that you know at this point that x plus 1 is in the exponent. So when you write your answer, I need you to write it as e raised to the x plus 1 with clearly having that x plus 1 in the exponent there. Here it cancels, v equals 2y. So my last step is going to be divide by 2. So now y is alone, so I can say f inverse of x equals e to the x plus 1 in the exponent divided by 2. Again, just be really clear what's in an exponent. B, same idea, switch x and y. X equals 10 to the 3y plus 1 minus 5. And we have to isolate again. You have to isolate, in this case, the thing that's being raised to the exponent. So that 5 needs to come over. X plus 5 equals 10 to the 3y plus 1. Then what? What gets rid of a 10? Don't say divide. Whenever you're getting rid of the base of an exponent, you have to take a log. So I would take log base 10, which is just log. So log of x plus 5 equals log of 10 to the 3y plus 1. And just like showing that this was in the exponent, putting parentheses here is really important because you have to show that that x and the 5 are both in the log. Okay, that's going to cancel. So I have log of x plus 5 equals 3y plus 1. And now I just have to get y alone. So log of x plus 5 minus 1 equals 3y. Divide by 3. My answer is going to be g inverse of x equals log of x plus 5 in the log minus 1 outside of it, all divided by 3. Okay, so those are inverses. The last couple down here is some practice solving equations. Solve the following algebraically, round to the nearest hundredth if we need to. So again, algebraic means that you can't just do y1, y2 calc intersect. It's a great way to check, but you can't just throw them in that way. What would you have to start with A? You have to isolate the base first. What's the base in part A here? The base is the thing that has an exponent attached to it. So it's the 5. So this 5 needs to get isolated. What would you do first? Add 9. 3 times 5 to the x equals 108. Remember, I hope none of you are even a little bit thinking multiply these 3's in. We've talked about that a lot this year. You can't because 5 has the x on it, the 3 doesn't. So instead, you have to divide by 3. And I think that will divide nicely. 108 divided by 3 is 36. So now I have 5 to the x equals 36. Now how do I get rid of that 5? Not dividing, taking the log base 5. Log base 5 of 5 to the x equals log base 5 of 36. Now x is alone. If you have the log base key on your calculator, you can just go math, alpha, math, log base 5 of 36. If you don't have that on your calculator, how do you type it in? You type in log of 36 divided by log of 5. Either way, you get the same answer. To the nearest hundredth, it's going to be 2.23. All right, and the last one, solving a log equation. The log piece is already isolated, so how do you get rid of it? Exponentiate. When you exponentiate by x plus 4. So that gets it to cancel over here, and I have 17x minus 4 equals x plus 4 squared. How do I deal with x plus 4 squared? It's not just x squared plus 16. This is a boxing situation. So x plus 4, x plus 4. I'm going to have x squared, 4x, 4x, and 16. There's that middle term. So 17x minus 4 equals x squared plus 8x plus 16. And what? Make it equal to 0. So 0 equals x squared. 8 minus 17 would be negative 9x. And 16 plus 4 would be plus 20. Factor it. X minus 4, x minus 5. We get x equals 4. We get x equals 5. Before you box that in, what do you have to make sure of? You've got to make sure that that doesn't make either log or any log negative. Plug 4 in, it's going to be a fairly big number, minus 4. And the log base is still positive, it'd be 8, so 4 is fine. And for 5, it'd be log base 9, so that's fine. 17 times 5 minus 4 is definitely positive. In this case, there's no rejecting. Okay, how'd that go? All right, let's look over the review sheet. All right, so just to talk through things quick, I'll do one of these sketching graphs first, That's one of the, I'll do the first question with you so you can get started on it. Log skills, evaluating with and without a calculator. That means the second section here, knowing what a log means. Log base 3 of 81. Now I won't know if you just plug that into the calculator. You definitely can, but just for future math classes, it's going to be way more helpful for you if you can understand what that log means. Remember, log means 3 raised to what power gives you 81. The answer is the exponent. So what would the answer be here? It'd be 4. And again, I will never know if you just do the log base 3 of 81 because that'll give you 4, but you will have math classes at some point that don't let you use a calculator. So it's a good idea to understand what a log means. So I would say number 3, number 7 for sure, number 9, those ones you can do without a calculator. Maybe number 4, maybe number 5, maybe number 6, but for this year, get the answer any way you can, but at least try to think about, can you do it without a calculator? Switching between logs and exponentials, that's just knowing, a log undoes a base, and exponentiating gets rid of a log. The properties, we just did those 3 property rules in the warm-up. Domain we haven't talked about. So if you look on the second page, log properties to condense, log properties to expand. Domain, when it says domain, this has come up in the homework a couple times now. What does that mean? Remember, domain means what's allowed inside a log, and we always reject logs that are negative or 0. So set inside greater than 0 if I ask for the domain of a log. All right, log equations, again, we just kind of went over those. Just so you know, 29, solve that graphically. The other ones should all be algebraically. And then applications from yesterday, know those formulas, they're written on the front. Continuously means PERT. Compounding not continuously would be that formula. And if it's anything else but growing exponentially, it's the first formula. But those are the last 3 questions. Okay. If you want to start a blank sheet of paper for the homework tonight, is obviously to do this. I'll do number 1 with you. Find an equation for f inverse of x. Use tables to sketch both of them on the same set of axes. State the domain and range. Okay, so this was like the first day. So I'm going to go to a blank page. Let's see if I can know how to do that. Insert blank page. Perfect. Okay, so number 1 was f of x equals 2 to the x. Part A said to find the equation for f inverse. So we just did some of those. What do I do if I want to find the inverse? Switch x and y, so become x equals 2 to the y. Then what? I want to get rid of 2, so how do I do that? Log base 2. Log base 2 of x equals log base 2 of 2 to the y. That cancels, and I have f inverse of x equals log base 2 of x. That's part A. Okay, part B says to make tables for f of x and f inverse, and then sketch the graphs. So here's f of x first. Remember what x values we always used if I want to just graph the exponential? Yeah, I used a couple negatives, so -2, -1, 0, and a couple positives. And you can use your calculator if you really need to, but I always start at the 0. 2 to the 0 is, I think the 0 is 1. 2 to the first is 2. 2 squared is 4. So if I go the other way, what would 2 to the -1 be? Remember, a negative exponent just means flip the positive version of it. So instead of 2, it's going to be 1 over 2, or 1/2, which would make 2 to the -2, 1/4. How am I going to get a table for the inverse? What's the easiest way? All right, just switch x and y. So 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2. Okay, and then it said to sketch a graph of the original function and its inverse. So -2 1/4 would be about there. -1 1/2, 0 1, 1 2, 2 4, like that. And when you graph an exponential, you should show the asymptote. Where would be the asymptote for this graph? It'd be y equals 0. For f inverse, I have 1/4 -2, be right about there. 1/2 -1, 1 0, 2 1, and 4 2. And make sure when you draw that graph, you don't go over its asymptote, which would be x equals 0. And the last step, anytime you graph two things, I don't know if I made a big point of this on the first day of notes, you really do need to label them. If there's more than one graph on a same grid, you have to show which one's which. So label f of x, and then label this f inverse of x. Okay, last part, part C, asks for the domain and range of both of them in interval notation. So for our original graph, f of x, what's the domain of this exponential? The blue graph goes left and right forever, so -infinity to infinity. And the range of it doesn't go down forever, it only goes down, but stops at that wall of 0, parenthesis on 0, because it never gets to it, and then up to infinity. And what should the domain and range of the inverse look like? It should be flip, because domain is x, range is y, so we flip them. And you can see the domain of the red graph, it goes left to 0, but not including it, because that's where the asymptote is, right to infinity. But for the range, it does go down forever and continues to grow forever, so -infinity to infinity. Okay, so that starts you off on the review sheet. You can finish that off for homework. Before the test tomorrow, I would say look over this warm-up also. As I told you, there would be a graphing question similar to that. When you see a function like h of x equals log base 2 of x plus 8, where's the asymptote there? You did this a couple days ago, so it's in your packet. But the asymptote is going to be at -8. Because when I'm thinking domain, I'm thinking, okay, the inside has to be greater than 0, x is greater than -8. Greater than -8 means the asymptote is at x equals -8. Don't forget, I need to see that on your graph. You have to draw in the asymptote. And then just pick nice numbers. Look at your table when you plug it into your calculator. Pick nice numbers to graph the rest of it. Okay? Let's see how we're doing. Okay, lastly, let's just fill out the what you're not allowed to forget sheet quick. If you don't have it with you, maybe write it down on a separate sheet of paper so that you can fill it in when you get it back. But to know for the end of the year, important things about logs. What a log is really the most important thing from this unit. So I would say write down that logs undo exponentials and vice versa. And if you want to put an example, that's where I have, if I've got log base b of b to the x, those cancel and I get x. By the same token, if I have b raised to the log base b of x, exponentiating cancels logs and you get x. Other important things, log really means log base 10. ln really means log base e. So you use those to get rid of bases of 10 or bases of e. And then finally, talk about how to do it on your calculator. If you have a new calculator, you can just go down to math A, which is where that log base key is. If you have an old calculator, you might want to write down that log base b of x, I can type in as log of x divided by log of b. Okay, so get that review sheet done for homework. Send me pictures of that, or show me in class if this is a different year. And tomorrow will be the test. So do some review for it. Let me know if you got any questions, and we'll deal with the test tomorrow. Good luck.